Estimate activity durations. This is a process of estimating the number of work periods needed to complete each individual activity with the estimated resources. So, the length of a work period is something that is typically defined as part of your schedule management plan when we discuss the different units of measure that we'll be using. The number of estimated resources we have will have an impact on how much an activity will cost to complete and also on the activity's duration. And this becomes a very iterative process as we kind of go back and forth and make trade-offs. Perhaps we increase the resources or change the resources, which will have an effect on the cost and also change the overall duration. We have a large number of inputs coming into this process because obviously there are a lot of things that can affect how long an activity takes to complete. With tools and techniques, we see numerous estimation techniques. And for our outputs, the duration estimates and our basis of estimates will be our most important takeaways here. Some terminology and considerations when it comes to estimating activity durations. When we discuss effort, that is how many units of time will it take to complete an activity. So we can express this as labor hours, days, weeks, but we want to think about this in a continuous manner. So if I tell you it will take 40 hours of effort, that's not to mean that we're going to work 40 hours straight. That 40 hours is going to be broken up based upon the availability of the resources to commit themselves to that activity. Duration refers to the number of work periods needed to complete an activity. So we have the example here. A resource spends 10 hours of effort over 3 weeks of duration reviewing a specification. Maybe they're only available for 3 hours and change each week, or maybe the specifications are being released incrementally. The number of resources is also a consideration. Increasing the number of resources does not always reduce time. Especially in the world of software development, adding additional developers can actually increase complexity and make work slow down. I also like to use the example of trying to prepare dinner. The first couple people to go into the kitchen are extremely helpful, but by the time you get to the seventh or eighth person in there, well, at that point they're not really doing a whole lot. And this refers very directly to the law of diminishing returns. Again, think about adding more people into that kitchen, thinking that somehow it's going to increase productivity. But having it so crowded and having so much noise from so many people talking can actually make everybody less productive. The advances in technology. If we have new technology available, that may impact what resources we need or in what amount we need them. And the motivation of the staff. Student syndrome refers to a planned procrastination. It's where we understand that there is a deadline. If I know that I have 8 hours worth of work and I have a 40-hour week in which to do it, student syndrome says I should wait until the very last day and do all 8 hours of work at that point. This causes unnecessary stress and a hurried approach that could have an impact on quality. Parkinson's law is another consideration we have to take into account, which posits that work will expand to fill the time available. If I give you 16 hours to perform an activity, even if you could realistically do it in 8 or 12, you'll typically find a way to make it last the full amount of time that I'd give you. Inputs into this process includes our project documents as we look at our team assignments. So what staff do we have available? We have our resource breakdown structure. So again, anytime we see the words breakdown structure, we know we are dealing with a tree diagram, which is going to be a hierarchical structure of identified resources by category and type. Our resource calendars. Anytime we discuss the word calendar, it identifies availability. So a resource calendar is the availability of the resources. So on what days and for which shifts will these specific resources be available? This could refer to our human capital, it could refer to tools, heavy machinery, equipment, facilities, or even raw materials and when they would be delivered. We also want to go ahead and include information, if it's necessary, about the experience or skill level and possibly the geographic location of our resources. Availability can be listed for the activity level or for the overall project level. We also have our resource requirements. The skill level of resources will influence the overall duration. If you think back to the first time you ever tried to cook breakfast by yourself, I'm sure you probably made a little bit of a mess in the kitchen. But as years go by and more practice is had, you can kind of crack the eggs into the bowl, whisk them up real fast, and prepare something in just a couple of minutes. We're looking now at various estimation techniques. Analogous estimating is a type of top-down estimation. If we look at our WBS, a top-down form of estimation involves assigning a number to the top of the hierarchy. So perhaps I say it will take 6 months to complete this deliverable. And then we have to figure out how much time we give to everything beneath it. This is not a very accurate means of doing this, unless we have some very recent and relevant experience with a past similar project. There will always be some degree of difference between projects. If two projects are exactly the same, then it's not really a project because now the deliverable is no longer unique. This is extremely fast, so this is very useful in the beginning portion of the project lifecycle, especially if we're doing a feasibility study to determine how long it will take to do everything and whether or not we'll be able to meet certain externally imposed deadlines. We don't want to use analogous estimating for the entire project, though. The lack of accuracy can come back and give us issues down the road. Parametric estimating is another type of analogous. I like to call this analogous with math. So what we're doing is, instead of just making adjustments for known differences, we're doing a more mathematical approach. Instead of just shifting things a little bit, we're kind of looking at how much work can a resource do within a period of time, and then looking at how much work needs to be done. So within our example, we see that we have a resource that can install 25 meters of cable per hour, and we see that we have 1,000 meters to install. So we're able to calculate that the duration would be about 40 hours. Finally, we have our three-point estimating. Three-point estimating involves talking to the practitioners, the people that will actually be doing the work, and asking them for three numbers. What is the most likely amount of time that it will take to complete a certain activity? But then we also want to know a pessimistic estimate, which involves pretty much all of the original assumptions about that activity being incorrect or possibly having some aspect of the plan on how we are going to execute that or the steps that we'll be taking have to be modified or changed somehow. But then we have the optimistic estimate. If things go better than we had originally anticipated, if things are just absolutely awesome and the stars align, what is the shortest amount of time that we can complete this? By taking these three numbers and dividing by 3, we can come up with our triangular distribution or simple average of these three-point estimates. With the bottom-up estimating, this is the most accurate form of estimating available. The trade-off is it is the most time-consuming. This is where we go down to the individual activities and we start aggregating how much time does it take, how much money does it cost, and we roll that up into the WBS. And then we roll up those work packages and those planning packages up into the control accounts, and we roll that up until we get to the very top, up that deliverable level. So it will be very time consuming. It's the exact opposite of that top down, the analogous or the parametric version of estimating. We ultimately want to do some type of bottom-up estimating. Otherwise, we're not going to be able to have a high level of confidence when we're preparing our schedule. Under data analysis, we see our reserve analysis. We may want to involve reserves within our schedule to account for risk events that may or may not occur. So how do we determine how much to put in? We can use quantitative methods. So we can do a Monte Carlo simulation, which is a random iterative computer model that will tell us within a roundabout range how much reserve do we need. We can go ahead and just select a percentage of the overall activity duration. Or we could just go ahead and say this is how many work periods we'll set aside as a reserve. And it's entirely up to you as you develop your various management plans to determine how are we going to set aside reserves. The two types of reserves that we do see the most are the contingency reserves. These are for known unknowns or identified risk. They are included in the baselines, and that is something that we will have control over, as opposed to a management reserve, which is an unknown. This is an unforeseeable risk event. Nobody's going to look at you and wonder why you weren't able to figure out that that was a possibility. Since these are for things that we cannot foresee, it will not be included in the baseline. These will be controlled at a higher level than the project. Now, that might be at the project management office, the program manager, it could be the portfolio manager, it could just be senior management or the sponsor, perhaps. To give you a quick example of the difference between contingency reserves and management reserves, contingency reserves, we may go ahead and set aside 5 days of reserve to account for inclement weather if we're doing a construction project during thunderstorm season. Now, that 5 day of reserves may be sufficient for thunderstorms. But what if now we're hit by a major hurricane and we've lost utilities for the entire area for the next possibly 90 to 120 days? There's no way that we could have reasonably foreseen that this was a possibility. That tends to be more of a one-off, so that is something that would be dealt with through management reserves. So outputs from this process, we have our duration estimates. Now, when we're dealing with estimates, these are basically guesses that we are trying to get to as scientifically as we possibly can. We have an estimated time required to complete each activity. And with duration, we do want to keep in mind is a function of the effort required and the availability of the resources that we need to perform the work. Duration estimates can be a range. The basis of estimates is kind of a reminder. How did we arrive at these numbers? Who did we speak to? And what type of formulas or assumptions did they have when they came up with these estimates? The basis of estimates could also include a range of estimates or an overall level of confidence for them. With our project documents updates, the activity attributes. So now that we have some information about how long these activities should take based upon these estimates, we can go ahead and record that information. With the assumptions log, the skill level of the practitioners involved in the actual work. It can be very difficult to accurately assess their skill until we're able to observe them working. And their overall availability. We might assume that we can have them for 10 hours per week, but might not be the case. With the risk register, if we identify any areas of specific concern or uncertainty, we would definitely want to go ahead and document that. And any lessons learned that we are capturing as work is being done. So that way it can help us on future similar projects. We've just finished discussing estimate activity durations. For quick learning assessment, what types of constraints must you consider when doing this? We're going to have to consider both the physical and the regulatory environment. What types of EEFs and OPAs must you consider? The enterprise environmental factors include resource availability, skill level, and possibly environmental constraints. Organizational process assets. We may have lessons learned, policies for estimating, or possibly templates. Who should prepare the duration estimates? The person assigned to do the work should generally prepare the estimates. What is the difference between effort and duration? Effort's the total amount of labor needed, while duration tells you how long it will take for that labor to be done. Describe analogous, parametric, and three-point estimating. Analogous is looking at a previous similar project as a basis for the duration of the current project. Parametric looks at the historical relationships with specific project parameters to come up with a new estimate. Three-point estimates involves developing a pessimistic, an optimistic, and a most likely estimate, and then coming up with a simple average of the three by adding them together and dividing by 3. What information could be included in the basis of estimates? The basis of estimates can include information such as how the duration estimates were developed, assumptions, constraints, confidence levels, formulas, or any other information that we use to arrive at the estimates we will be using.